I'm going to give you the how and why of auto-executing functions in JavaScript. So that's the thing that looks like this. When you've got a JavaScript file where you got this little bit in the head and this little bit at the tail. Technically, I believe the correct term for that is an immediately invoked function expression, and I'm just going to call it an IIFE for short. Plus, that's a pretty good name for it because a lot of the use cases for it are very iffy indeed. Now, I'll go ahead and open up the Tools and JavaScript console and clear out all that mess that has nothing to do with the example here. So first I'm going to show how it works so you know that it's not magic. And to understand how it works, there's three basic principles that we need to grasp, which is they're literals, expressions, and then a little bit about math. So first, let's take this literal function. So the function answer console.log 42 close bracket. This is a literal function. And when I run this program, that function will get evaluated. It'll be hoisted up to the top just like variables are. It'll get evaluated, and then answer will be a name that's bound to that function that I can call, and then it calls that function. So no surprises here. 42 is logged to the console. That makes sense. Now, before I go any further, I want to give a little bit more of a differentiation between what a literal is and an expression. So first I'll start with a literal number. So if I type in 42, that returns 42. Okay? Now I can wrap it in parentheses and it returns 42 and then returns 42. So the parentheses actually cause the 42 to be evaluated, and then the expression as a whole gives back 42. So if I do an assignment, this also does about the same thing. I can type in answer, and I can see that answer is 42. So in all these cases, nothing too interesting going on. It's just different ways of getting 42. I can get it as a literal value, I can get it as the result of an expression, or I can get it as the result of an assignment, which is in turn also the result of an expression. So now, so every number in JavaScript gets a method called toString. And so if I do answer.toString, I should get 42, and I do. I get it as a string as opposed to as a number. Now, if I wrap 42 and call .toString on it, that expression also returns a number which has a method toString, which then gets stringified as the string 42. So nothing too crazy there. However, if I do 42.toString, you would think that again I'd get back 42 as a string, but in fact I don't, because I'm calling the toString on the literal 42 and not on the evaluated 42. Okay, so this is just a little quirk in the language where sometimes literals behave differently than evaluated expressions. So to go back, no, we'll go forward. All right. So let's just think about math real quick. This doesn't actually apply to JavaScript, but just as a way to reason about it and kind of comprehend it a little better, think of the expression 2x plus 2y equals 2z. Now, you could take on the left-hand side of that, you could factor out a 2 and then have 2x plus y equals 2z. And you've got the parens around there because the 2 applies to both the x and the y. And then you could divide both sides by 2 and you would get x plus y equals z. So from here, it shouldn't be too big of a jump to kind of understand how an anonymous function invocation works. So I'm going to take my function here, and I'm going to take the say out of here and take the say out of here, and then I'm going to wrap the function in parentheses to force it to be evaluated, just like with the number 42. So just so that's very clear what's going on. So I kind of just factored out the name of the function. And then when I execute it, boom, it works as expected. Now I do want to show, again, that the function literal can't be called directly. Something has to cause it to be evaluated first. So if I just put it in this way, I get an error. And if I go back to the way that works and take out the white space, then I'm left with what you commonly see for an IIFE. And no good IIFE is complete without a use strict. I'll get more into that in just a minute. And then I personally like to put my paren on the outside. You can do what you want. I think it's more aesthetic that way. But there's no real reason to argue about it. Now, let's talk a minute about the kind of evil people that punch babies. Because there's a lot of guys out there that do really weird stuff like this, that causes a function to be evaluated as an expression without using parentheses. And so some of them claim that they don't think parentheses look nice, or that they're saving a byte and that network traffic is really a big concern to them, and so that byte makes all the difference or something. I want to show you that it works, but I also want to encourage you not to do this kind of stuff because it's confusing. I mean, having the parentheses isn't necessarily the most intuitive possible way to go about it, but we're very used to, in programming, seeing parentheses around things to know that that gets evaluated first. You know, so if you have a parenthesis around a 5 times 3 plus 1, and you've got it around the 3 plus 1, you know that that gets evaluated first. So at least there's some logical correlations you can draw. Whereas with these tricks that you see here, and there's probably half a dozen more, hopefully not that many, but maybe. So with these kind of tricks here, there's no cue to the average person who's used to doing programming as to what the heck it means. And when you see it in code, it's very confusing. Even if you know what it means, it's confusing. So all I can do is beg, think of the children, people, and don't do stupid things that are confusing. Now, hopefully you understand how the IIFE works. Now I'm going to go into why we would use an IIFE. So, in a word, or in a sentence rather, the purpose of an IIFE is to give scope to a file or block. And I will go ahead and give some examples of that. So, now this problem can't really be solved by an IIFE, but at least it kind of demonstrates the problem in general. So in JavaScript, you can declare things 11 times, and it doesn't throw an error. It seems like it should. I mean, this seems like this should not be a valid program, but this right here, this is a valid JavaScript problem. Yes, it's a valid JavaScript problem, also a valid JavaScript program. And So that's a little contrived, but people do declare a variable multiple times, expecting that variable is being reinitialized, or that it has different scope because it's inside of a for loop or a while loop or some other type of block, and that's not the case. So to give you a more practical example, let's look at my pirate array.js, where what we can do is take an array and push some obscenities onto it. There's an init function and there's a push obscenity function. Now, if this was just a file that got loaded into the browser, it would load just the same as I'm doing here. Boom, done, loaded, right? And then let's say I've got my smurfblocks.js, which is maybe a little bit more involved, but essentially all it's doing is adding more blue to an RGB pixel value. So I'll take that same thing and load it in. Oh wait, it also has an init function. So now what's the true init? Turns out it's whichever one was loaded last. Now, if I were to wrap both of these in IIFEs, I wouldn't have the problem of the inits being in conflict with each other because they would both belong to the IIFE scope. Does that make sense? So just another quick example. So here we have var b equals 7, and then I can put in here var b, and then I can console.log actually, let me do this both ways. So let's do var c equals 8, and then var c, and then console.log. You might expect both of these to behave the same, just intuitively at a glance, but they're going to behave differently. So I'm going to log, let me just call this one C, and then call this one B. So C is 8 and B is undefined. And you might have expected differently, because you might have said, well, here's C and it's being assigned 8, but then now I'm redeclaring C, so if that's valid in the language, it would make sense that it would reinitialize C to nothing. And then here we have B initialized to 7, and then we redeclare B, and from our previous experience, seeing that C retains the value 8, we might think, oh, well, B, even though it's being redeclared, will retain the value 7. But there's only one C, regardless of the number of times it's declared, per scope. Likewise, here we have two scopes. We have the global scope that B is in, and then we have the function scope in the IIFE that B is in. And so those two B's are different B's. Okay, I think that point is pretty clear. So the next issue, let's see, yep, I already talked about that, is that we're still in grave peril, okay? Because let's say that we forget to put var b, and we do b equals 8. So console.log b. So I'll run this again. Okay, and now both b's are 8. So even though this b is inside of the function, it gets the scope of the outer b. And the way to resolve that problem can be with use strict. So let's give a different example. So I'll do d, there we go. I'll do d equals 8, and I'll console.log d, and I'll declare d down here. Well, what's actually going to happen is d is going to get hoisted to the top. So let me not declare d, because this is a much better example. because it will actually work if I declared it all, because it would get hoisted to the top. So D doesn't get hoisted in this case because it's never declared. So when D is assigned here, it just becomes a global. So now I can see that D has become 8, but D was never in the scope outside of this function. So the IIFE wasn't able to capture that D. If I put in use strict, however, and now I have to use a new variable name because the global space has been polluted with a D. So let's go ahead and go to E, and I run this with use strict. Now when I run it, oh, I actually didn't show my point there because I actually put B, but it works the same. Let me run that one more time just to show, and then I'll go back to this one. Okay, because I don't want you thinking that I'm telling you lies. Okay, whoops, and that's still, this whole thing needs to change. There we go. Okay, there. Now that is correct, and I proved my point. Okay, moving on. So now with use strict, if I try to assign E, instead I get an error that E is not defined. So in the case where I have here in my, because it's very common for you to use the same convention from one file to another. So you might have an init function in 2 files that you've created. You might use a variable such as fresh or first run or once to describe a certain process. And like I've done here, I've assigned fresh, but I didn't declare it. So even though this could be inside of an IIFE, and this could be inside of an IIFE, if I don't declare fresh and I'm not using strict, then that fresh can still hop into the global scope and I can still have conflict between the 2 files. So it's very important to always use strict and to always use an IIFE. Now, that's not the only problem that there is. There's also other problems in this code. For example, you would think that if I do 007 var num equals 007 num, I get 7. So it's like I'm just using the zeros for formatting purposes. I want things to be aligned straight so that I can tell. Wrong. Because although it works in that case, if I try the same thing with this 032, well, that's odd. The number's 26. Because actually, even though it looks like a decimal number, because there's a leading 0, JavaScript can't decide what it is and then determines that it's an octal number instead. So as a tangent, the way to always assert that something is the number type you want it to be, you use %, and you never leave the radix out. You would do something like %3210, or if you wanted it octal, an 8, or if you wanted it in hex, I don't even know if that'll work. Okay, it will. Then 16, and so forth. In strict mode, octals are not allowed as literals because it's confusing, it causes errors, it's unintuitive. Hex has a prefix, but octal does not. If it had one like that, then it might make sense. But anyway, so strict mode doesn't allow octal, and strict mode does some other nice things. For example, I don't want to go too much into this, so I'll skip that part. But I believe that if you declare a Boolean object instead of a Boolean literal, it will always return true when it's not in strict mode. But in strict mode, if it's false, it will return false. So there's just some oddities in the language that are things you only run up against by accident that strict mode will fix. So I think we covered all the bases there. Oh, and one more thing. So a lot of times you'll see IIFEs inside of loops like this, and I think that's completely bunk because it's just confusing. Like, what does this mean? Now the reason that people get to this point is because before they'll have had something like, well, let me show you where this comes from. This comes about because somebody has a function that looks more like this, Oh, that was supposed to have a number there. Doesn't actually affect the demo here, but I'll put it in just for funs. Okay, so somebody has a function like this, and what they're expecting is that, and this would normally not be a set timeout, it'd be like an asynchronous request with like jQuery or something, right? But they're expecting that they're looping over this and they're passing in this variable, or the variable's in that scope, and so therefore, when it console.logs, it'll console.log 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. But in actuality, what happens, and people get confused, is it prints out 10. Now this actually makes sense if you consider what's really happening here, which is that the function gets hoisted, and then it would be given some internal memory reference, so we'll just call the function ABC. And now it's very clear why this happens, because I is in the global scope, or in the file scope, because this should be inside of an IIFE anyway, already, as a file. So I is out here in the global scope, and then I is being changed lots of times. ABC is not being called for 4 milliseconds, and this loop is going to exit before the set timeout is ever reached, and it couldn't be called until the loop exits anyway, because it has to reach the end of execution before it will go back into the event loop and pull out the set timeouts or asynchronous requests or whatever. So anyway, and so at the end, it makes sense that I will be 10, and that it will simply call that function 10 times and you get the number 10. But it's not intuitive when you put it in the loop. Likewise, taking this right here, although you fix the problem in terms of the technicality, you don't fix the root of the problem, which is the misunderstanding. So although this works as expected, you put the IIFE around it, you're able to capture the I, pass it into the IIFE. Now it's a copy of I that's in the scope of the IIFE. I mean, this is still kind of complicated to explain, right? But if I do what's going to be done anyway, I do the same thing that I was just talking about. Take the function out, call it ABC, or I mean, and let's, there, I'll give it a real name. Okay? And again, I forgot to put that in there. And then put that here. Now I don't need the parens around it because it makes sense without the parens, although they're both equivalent. Now this makes a lot more sense. Now you can see how the I is being passed in as index. It gets the scope of think before speaking, and then when the timeout is reached, it's going to have a copy of I that is to that scope, and that it works as expected. So now this has gone from black magic to something that someone can look at and reasonably understand. And then here it is, same thing we just did. So in conclusion, IIFEs are good. Every file should start with an IIFE, and the first line of that IIFE should be use strict. IIFEs should not be used in loops. They should not be used in convoluted, complicated ways that are going to confuse other people and yourself, because you will forget why you did it. You will forget what it means. You're just a human like the rest of us. So use IIFEs. Write good JavaScript programs, but don't go crazy, okay? All right? Think of the children. Think of the children. P.S. If you're learning JavaScript as your first language, I'd highly recommend Python or Ruby. Golang is also a great example, or something else. Something that has structure, something that's a little easier to reason about, just not PHP. It's just that JavaScript, if this is your first language, there's so many little idiosyncrasies that came out of the short development cycle that make it a really difficult language to learn and master without other experience. But I mean, if you've got a tutor or you're really willing to invest the time in figuring out stuff like this that is only in the language accidentally, or rather, the hacks the hacks are on purpose, but due to things that were left in the language accidentally or without enough thought or enough seeing how development would work out. Um, Welcome to JavaScript, where you can have it your way, but don't get crazy.